Okay.
Because me and my boyfriend have these competitions between who can get the furthest in one day. He always wins.
Alright, here we go.
Because he has more time. He doesn't go to school, so that's like his.
So, given these functions below, they want us to use f of x, capital F of x. So they want us to do the antiderivative of the function they've given us to find f of x and f prime of x in terms of x. So notice when you look at this, first of all, it is not in terms of x. It is in terms of t. So we're going to use this stuff and the fact that there's an x up here to find these things in terms of x. So f of x is going to equal. The other thing is, like this kind of stuff, to write this out seems like kind of a pain, but on a free response question, writing out the notation a lot of times is worth a point. So if you just write their notation correctly, you get a point for that, even if you end up calculating the problem wrong. So that means this is going to be from 1 to x of 4 t minus t squared. I need to take the antiderivative. So that's going to be 4t squared divided by 2 minus t cubed divided by 3, and that simplifies to 2t squared, plus c by the way, but we are not going to put the plus c because we're about to plug in. We have actual bounds, so we can plug in. Minus 1/3 t to the third. Now go ahead and plug in x as your first value minus 1 as your second value. Take a second and do that real fast while I turn on her test. So.
Yeah, I'm listening to my club music.
Oh, yeah, I was about to say, tomorrow's your clubbing day if you don't work.
Yeah, but I work or something.
Just
Yeah.
eating e-commerce.
Hmm?
E-commerce.
Right. This is my classic dance move at the club dance.
You look like you're emoting.
All right, so Catherine, see if you can get into it now. I think I just opened it. Yes.
I did a whole back so I can go back to Miss Irons because I forgot something.
Okay. All right, go ahead.
That or I move my hands like this.
Did that work, Catherine? Okay.
Or sometimes
I'm
I go
just
retro.
curious, how much do you think you're learning while you're listening to club music?
A lot, actually. It's really funny because I was just taking I was doing my anatomy, like Kahoot thing for review, and during like our lectures and stuff, I was listening to like my theater and like movie playlist, and I was listening to that going over it, and before going into the class, I was like, I don't feel like I know anything, and like I feel like I'm gonna fail this Kahoot. But then I went in there and I was listening to the music, and I recalled everything. So I can do like the same thing with club music.
Well, except for, does it have words?
Yeah.
Yeah, it does work. It won't work. There's lots of research on it.
It worked for all my movie songs and stuff.
Interesting. Probably just
Maybe I just know things.
you end up getting that.
That's what I got.
That's what you should get. Good.
See?
Okay,
I'll use it
so
first.
now we did the first part that we found. That's f of x because that's what we did all of that. That's f of x. So f of x is that. But they also asked us to find the derivative in terms of x. So because our original is in terms of t, so we want to find the derivative in terms of x. So I'm just going to take this that I got, and find the derivative of it. That's easy enough. We've been doing that forever. So f prime of x is going to be 4x. The power rule is going to be minus. If I pull the 3 down, the 3 and the 1/3 cancel, so it's going to be just x squared. So that's your f prime of x. All right, so far so good?
Yeah.
Pretty easy. All right, so this one we're doing the same thing. So f of x is going to equal the antiderivative from 1 to x of cosine t dt. We'll go ahead and find the antiderivative. All right, what's the antiderivative of cosine t?
Oh, negative sign.
The antiderivative.
Oh, the antiderivative? Is
Sine t.
sine.
Let's see.
The derivative of cosine is negative. The antiderivative is not.
Cosine makes cosine.
But I thought
Okay.
sine, the antiderivative. I'm confused.
Okay, I know, and it totally can be confusing, and I think with the trig things it's even more confusing because you don't have like just a straight up rule. But if I have sine of x, and I ask you to take the derivative of sine x, what is the derivative of sine x?
Cosine.
All right, so the antiderivative of cosine is sine, right? If I ask you to take cosine x and find the derivative of that, what is the derivative?
Negative sign.
Negative sine. So the antiderivative of negative sine is regular cosine. The antiderivative of regular sine would be negative cosine. Okay, so the antiderivative of cosine is negative sine. So that means that I have negative sine. I'm going to replace t with x minus negative sine of 1. And I just said negative sine and it's not. Hold on. Sine, okay, so
Wait, so it is or is not?
it's not. I just confused myself. It's not. Because it's the antiderivative, not the derivative. Okay, so this, because we're not going to use our calculator right now, sine 1 is actually a constant. It's a decimal. If you put it in the calculator, sine 1, it's going to give you back a decimal. So we're not going to worry about putting it in our calculator right this minute. But this is f of x, f prime of x, because this is a constant. We just have to take the derivative of sine x, which is cosine x. All right. F of x equals the antiderivative. Okay, so look, what they've changed our bounds now. So instead of 1 to just x, I'm going to 1 to x squared. All right. All right, so we get to power rule this. So that's going to be t to the 4th divided by 4. And I'm going to plug in my boundaries. So that's going to be x squared to the 4th divided by 4 minus 1 to the 4th divided by 4. All right, x squared to the 4th. What happens when you raise a power to a power? What do you do with your exponents? Multiply. So So it should be x to the 8 over 4 minus 1/4. Right? That's your f of x. Now let's find our derivative. The derivative power rule, 8 gets multiplied, 8 and 4 simplify to 2x 7. And that would be, that's constant, so it's 0. All right, so really quick. Notice how when we did these up here, it got us back to the original function, just with the x plugged in, right? So I found the antiderivative and got that, and then when I found the derivative again, I got back to where I started, just with an x in its place. But when I did this one, I didn't get back where I started. So,
It's not right.
no, that's right. Why do you think I didn't get back where I started?
Because it's cute. Or because you have the x squared.
Because it's an x squared, not just an x. So let's see what happens with this one. F x. Derivative from 1 to x squared of 6t. So I'm going to rewrite that as 6x to the 1/2 power, or 6t, sorry, I haven't taken the antiderivative yet. All right, so taking the antiderivative, that's going to be 6t. I add 1 to 1/2, so that's going to now be 3/2. And that means I get to divide by 3/2, which is the same thing as multiplying by 2/3. And then I can simplify that. 3 goes into 6 twice, so I get 4t to the 3/2. That's my f of x. Oh, I need to plug x in now. So 4x squared raised to the 3/2 minus 4 times 1 to the 3/2. All right, so right here, x squared and then 3/2, the 2's cancel, and just leave you 4x cubed minus 4. And again, I didn't get back where I started. Let's take the derivative of that. It's going to be 12x squared. Well, we're not getting back where we started, but that's okay. It's because of this x squared. But there's a rule here that's kind of shaping up. So let's see. It's the second fundamental theorem of calculus, which, let me get the actual wording so I don't write it wrong. It says something about something and something. If then, if f of x, if capital F of x, big F, if big F of x is equal to an antiderivative from a to g of x, meaning some sort of function. F of t, where a is any constant then this is how you can find the derivative of that f of x. It's going to be f of g of x times the derivative of that bound. The derivative of g.
I think that's the change.
It's like chain rule. We're chain ruling our boundary though, not our actual function. So if we did this one, so what we found our f prime of x to be, I wrote it down on the page before, the first page. Our f prime of x came out to be 4x minus x squared. So f prime of x was 4x minus 4x squared is what it came out to be. Oh, no, minus x squared, not 4x squared. So, yeah. Okay, so they want us to use this, the second fundamental theorem of calculus to find it the same way. So we're going to use this little thing instead. So I'm going to take my boundary x and plug it into my function first. So that would be 4x minus x squared, and then multiply that by the derivative of that function. Well, the derivative of x is just 1, so it gives me exactly what I got, 4x minus x squared. That is certainly faster than doing what we did, which was to actually find the antiderivative, plug everything in, do the subtraction. So using the second fundamental theorem is faster. So this one, remember we found our f prime of x to be cosine x. So if we do it the second fundamental theorem way, we're going to take our bound and plug it in. So that would be cosine x. And then multiply that by the derivative of your bound, which is just 1. So it's just cosine x. Again, much faster. And it'll really show up on these. So on this one, it came out to be f prime of x came out to be 2x to the 7. And that's when we were like, okay, all of these got back to the original with just an x plug in, but this one definitely looks different. So let's try it this way. I'm going to take my x squared and plug it in. So it will be x squared to the third power times the derivative of that, which is times 2x. Well, x to the third, power to power, you multiply. So that would be x to the 6th times 2x, which is 2x to the 7th. This one came out to be 12x squared. Alright, so if I take x squared and I plug it in right here, that's going to be 6 square root of x squared, which is x, times the derivative of your boundary, which is 2x. So the square root of x squared is just x, so I have 6x times 2x, which is 12. And it's pretty simple, if we can just remember we need to do it. Now, the important things about the rule. Your a value has to be a constant. And then your other boundary, and remember, a is on the bottom and b is on the top. So that's important. We can switch them. Remember, we have a rule where we can switch them if we need to, which we won't have to. But, okay, so I have one here. My boundary on bottom is -2. That's a constant. And I have 2x on top. So let's find the derivative. So I'm going to plug in 2x where t is. And then multiply by the derivative. And then all you have to do is simplify this. 2 square root 2 minus 4x squared. And that's it. Because all they ask us to do is find the derivative. They didn't ask me to solve anything. We're all good so far? All right, the next one I have an issue.
Because the a is not
The a is a function, right? And the b is a constant. But our our properties of integrals will allow me to switch those two if I make the entire integral negative. So I can just make it negative antiderivative, and I can move the negative 3 to the bottom and put x squared on top. E of cosine. Now we're plugging in. So I'm just plugging that in there, so that's going to be e to the cosine x squared times 2x. And the entire thing is negative, so I'm going to put the negative in front. Now there's nothing wrong with this. That's the answer. More likely they'll move the 2x to the front and make it negative 2x e to the cosine x squared. Is 0 a constant? It is. And I would probably rewrite this, put the negative sign in front. So I'd write it as negative sine x, and then I would write it as cosine squared x. These are the same thing, cosine x with a squared on the outside and cosine squared x. They're the same thing. This is just the notation you're going to see. Like if they printed it in if this was a multiple choice test question, you're looking for your answer, it's going to go like that. All right, are we good so far? Yes, yes?
Yes.
All right. Okay. So now remember, when we're doing this is the second fundamental theorem is helping us find the derivative of the big f of x and the big g of x. So it's after we've taken an antiderivative when there's a function and a constant. So on this one, picture to the right is a graph of g of t, and the function f of x is defined by f of x blah 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 g of t. So this graph over here, and this is when I think, and actually you guys did really well on the test with the question that had a graph, but I do think that this is where it gets confusing, keeping track of what your graph is a picture of and what they're actually asking about. So my graph is g of t, as it says right here. So I'm going to put a g of t on it so I don't forget that this is g of t over here. And f is the antiderivative of the graph. If you take an antiderivative of the graph, what are you looking for? When you find an antiderivative graphically, what are you looking for? Come on. What did we just do a whole bunch of on the last test? An antiderivative graphically is the area under the
Yeah,
curve.
okay, what's the area?
So F is asking me for the antiderivative of G. So when they're talking about F, they're talking about the area under this curve. Is everybody okay so far? All right, so they're asking for the value of f of 0. So that means f of 0 is going to equal the antiderivative from -4 to 0 of the curve. So that means I'm finding the area under the curve from -4 to 0. All right, well, so -4.
What is a rectangle and a quarter?
Yeah, I'm going to do it as a rectangle and a quarter of a circle. 2 times 1 is my rectangle, and a quarter of a circle, the radius of 2, so pi r squared would be pi 4, or 4 pi, divided by 4 because it's a quarter of a circle, so it's just pi. So this one is just 2 plus pi. All right, this time, on number 2, I need f of 2. So if I'm looking for f of 2, it's the antiderivative from -4 all the way to 2. The area under the curve from -4 to 2. Well, look at it. -4 to -2, that already canceled out, and now I'm going -2 to 2. And it's symmetrical, right? So if this piece is 2 plus pi, then that piece is 2 plus pi, which means the whole thing is
4 plus 2.
4 plus 2 pi. Or you could put 2 times 2 plus pi, either way. All right, are we okay? All right, now they want the derivative. So now we're going to use the second fundamental theorem of calculus. So I'm going to take my, well, f of x equals this, -4 to x. All right, so the first thing you do when you're doing the second, finding the derivative, is I take my function and I plug it into my g of t. So that means this is going to be g of 2x, and then you take the derivative of that boundary, so times 2. That's your f prime of x. Now I just need to find it for 1. Is everybody okay with this and this notation? So this is the one on the test that everybody kind of struggled with, was kind of like this. It was just a function and you had to find the antiderivative. What's the antiderivative of f prime? F. What's the antiderivative of f double prime? F prime. So it's the same idea. So we're just finding the derivative of f, which is f prime. You have to still plug in the same way as before. Okay, so now I'm plugging in 1. So f prime of 1 is going to be g of 2 times 1 times 2. 2 times 1 is just 2. So I need g of 2. Well, what is g of 2? Remember, this is my g of t graph. So g of 2 is 1. Because I just go over to the graph where g is 2 and look up, and that's 1. 1 times 2 is 2. Is everybody all right? Okay, so it's the same thing here, but let's do it again just to make sure we know what we're doing. So I have f of x is the antiderivative from -4 to 2x of g of t dt. So when you're finding the derivative, so I want the derivative of this, I plug my function into my g of t, so I'm going to plug g times 2x, and then multiplied by the derivative of the boundary, so it's 2. And then I just have to plug in -2. So that's going to be g of 2 times -2. 2 times -2 is -4. So I need g of -4, which is -1. -1 times 2, which is -1. Oh, it would be, because I can't multiply. You're right.
I don't know how to do 5. I tried to do it on my own, and I was like,
Okay.
I'm silly.
So find the value of f double prime. Well, so this, because we've done it twice now, this is f prime, right here, right? So let's start there. Let's write that down. So f prime of x is g of 2x times 2. Well, the 2 is a constant, so it's still there. You know, when you find a derivative, we multiply by the constant or whatever. The derivative is still there. So f double prime is just going to be g double prime of 2x times 2. But because we have a function inside of our g, that you have to chain rule that. I have to take the derivative of the inside piece. So times 2 again. which means I'll rewrite it as G double prime 2x times 4. And we need it for 2, so F double prime of 2 is going to be G double prime of 2 times 2, not double prime, I'm sorry, that's just G prime. Let's take one derivative. We have to take one derivative. Times 4, so G prime of 4 times 4. All right, so G prime of 4. Now my graph is G, it's not G prime. So if I'm going to go to 4 on my G graph, what am I actually looking for at 4?
If it's positive.
Slow.
The slope. Remember, your derivative is a slope. So I need the derivative of G at 4, which would be the slope of G at 4. So the slope there is
One.
negative 1.
So it'd be -4.
Negative 1 times 4. So it's negative 4. Okay. Same idea. I'm going to give you guys like 2 or 3 minutes just to see how far you can get on this by yourself. I know they're both watching, but the one thing I wanted to make sure that you guys did is on the very first one, when you go to plug in -6, you have -1 at bottom and -6 at top, and that's backwards. So you have to flip it. Because the smaller number has to be on bottom, and -6 is smaller than -6. So when I flip it, it makes the whole thing negative. So when you find your overall answer, it comes out to be +1 because the negative in front is the negative that calculates as. Does everybody follow? Because your boundaries, the lower number has to be on bottom, which means you've got to flip them over and make the whole thing negative. And then on 2, 2 is as far as I got for this minute. So I got -8 plus 5.
Yeah, that's what I thought.
All right. Are y'all okay with this so far?
2, wait, how what?
Which one?
-8 plus 5. I got 6 plus 5.
So, it doesn't. I don't know how you're calculating it, but it's all of this.
Recalibrate.
So if you did a rectangle and a triangle and but either way, your rectangle and your triangle are both underneath. I did a triangle.
I